A distributed antenna system, or DAS, is a network of spatially separated antenna nodes connected to a common source via a transport medium that provides wireless service within a geographic area or structure. DAS antenna elevations are generally at or below the clutter level and node installations are compact. A distributed antenna system may be deployed indoors or outdoors. Concept: as illustrated in the figure, the idea is to split the transmitted power among several antenna elements, separated in space so as to provide coverage over the same area as a single antenna but with reduced total power and improved reliability. A single antenna radiating at high power is replaced by a group of low-power antennas to cover the same area. The idea was described in a paper by Sally et al. In 1987. These antennas have recently been employed by several service providers in many areas around the United States. DAS is often used in scenarios where alternate technologies are infeasible due to terrain or zoning challenges. The idea works because less power is wasted in overcoming penetration and shadowing losses, and because a line-of-sight channel is present more frequently, leading to reduced fade depths and reduced delay spread. A distributed antenna system can be implemented using passive splitters and feeders, or active repeater amplifiers can be included to overcome the feeder losses. In systems where equalization is applied, it may be desirable to introduce delays between the antenna elements. This artificially increases delay spread in areas of overlapped coverage, permitting quality improvements via time diversity. If a given area is covered by many distributed antenna elements rather than a single antenna, then the total radiated power is reduced by approximately a factor n1/n/2 and the power per antenna is reduced by a factor n/2 where a simple power law path loss model with path loss exponent n is assumed. As an alternative, the total area covered could be extended for a given limit of effective radiated power, which may be important to ensure compliance with safety limits on radiation into the human body. Precursors: prior to the invention by Sally et al., tunnel transmitters and leaky feeders had been used to provide radio reception in tunnels, mines, subway lines, and other indoor and underground spaces. Using Wi-Fi networks, using a distributed antenna system to create an area of wireless coverage, it is possible to use this technique to propagate indoor Wi-Fi for commercial uses. It is estimated that only about 5% of commercial Wi-Fi use a distributed antenna system. Placement of distributed antenna systems: distributed antenna systems may be placed inside buildings for increasing wireless signals within buildings. Often they are placed within large structures such as stadiums or corporate headquarters. Systems are also placed in the utility right-of-way on top of utility poles, street light poles and traffic signal poles. Regulations. United States Historical regulatory challenges arise at the federal, state and municipal levels. However, regulations have been getting promulgated at the state and federal level, with Midwest states leading the way with state-level regulations. Industry resources like the HetNet Forum also address regulatory issues in their conferences and communicate the outcome through their websites. Federal Communications Commission rules: the FCC has promulgated the FCC Pole Attachment Order 11-50, Michigan, the Metro Authority, which regulates access to the utility right-of-way, determined in 2004 that distributed antenna network systems are part of the landline infrastructure, and hence are subject to state regulation via an administrative determination. Ohio: the Public Utilities Commission of Ohio has issued a pole attachment rulings which require utility to allow distributed antenna systems in the utility right-of-way in August 2014. See also, macrodiversity. References